So hi, today I'm going to discuss the lead code question 424 longest repeating character replacement. So in this question, we are given a string and an integer k. You can choose any integer from the string and change it to any other uppercase English character. So the constraint given are there are only English uppercase characters present in a string, that is s. K is the number of replacement we could make, and we need to maximize a current substring containing maximum of the same character. That is, uh, for example, if we want to consider for a, then the entire string, that is maximum with only a's, and we could make two substitution. For example, if we are considering this substring and we want ki there is a b, we could also firstly convert into a, then it would be a, and since now it's a, we could consider it in our longest substring. So for example one, they have converted all the b's to a, so the final string becomes a. So the output is 4. For the second example, k is equals to 1, that is a substitution we could make is equals to 1. So what they have done is, for example, replace the 1a in the middle with b. That is b a b b. Here we could replace the middle a with b. Now it becomes b b b b. So the answer is 4. So the simplest way we could do this is by brute force solution. That will be key. We could consider for every character one by one. That is first for A, then we increase until we can with replacement and store it as the maximum. Then for B, continue till we can with replacement. Then compute replace with the maximum with greater than the maximum, but it would take a lot of time. That is, for every element in the array, that is n, and the maximum substring that it could go till could also be n. So it would take a n square complexity, but we don't want that. So my approach here is using a sliding window technique. So what I will be doing is keeping the count of characters in the current substring I am handling. That is a, for example, a b a, and uh, keeping the count of the characters I've replaced, and then sliding the window so that it covers the and gives a accurate answer in only one iteration. So to do that, I will firstly define a vector with int. Let's name it ls, and there are 26 characters in English, so 26 comma current count of everyone is 0. Now let's define the size we need to iterate to, so that is s dot size. Now the current answer, the final answer we need to store, let's keep it as answer and initially as 0, that is longest substring is 0. Then what we can do is define a maximum frequency variable. It will be used to store the current character we are considering the maximum substring. For example, if the substring we are currently considering is ABA, we'll find the maximum frequency element, that is A, and consider rest as replacements. So it will be that. So, and we will be starting from we'll keeping two pointers. So let's keep left one as 0, and for the right one I will be using a loop. So for I int I is equals to 0, I less than n, I plus plus. So for every time like we every time need to compute the maximum frequency element for the current list we are substring we are considering. So to do that, I will define a function also. So int current max, which will take in the current vector ls that I have defined. So int and ls. Now what I will be doing is int max that I need to return, let it be the first element of the array for the beginning, and then I will iterate from int I is equals to 1 till I is less than 26 I plus plus. If it is greater, then I will replace it. So to do that, I will use a max function, the current max and the new ls dot I. Then I could simply return the count of the current max. That is the current, if, for example, if I'm continuing ABA, the current count is 2. So I will return that. 1 second, I'm getting covered. So continuing now, now the next step we need to do is uh, for the like for every iteration, I'll add the current element that we are considering, that is ls dot I minus the a to, so that it the vector we are considering ls stores all the capital English characters, so ls plus plus. Then what I will do is compute the recompute the maximum, that is the current maximum frequency is max between max frequency and the max between the current ls, so that is ls dot I minus a. So now that we have it, what I will do is I'll consider the current index, that is I minus the left pointer. The I is the right pointer, left is the for the same place we need to add a 1. Then what I will do is consider the maximum frequency that uh, we are getting, that is a in this case, and minus it, so that we could check for how many replacement are actually being considered in our current scenario. So what I will do is the maximum replacement allowed is k. So if it is greater than k, then what I will do is I'll subtract the current left pointer, so that we are no longer considering it. And let's add and subtract this. Now that is subtracted, I will recompute the max. That is max f is equals to, I have made a function current max. So I'll input my ls into that. Now we will have a new maximum frequency. And now that it is done, I'll do increase the left pointer, so that the left pointer moves a step ahead. Now, if like we need to compute recomputing on max again and again. So if our current window is valid, that is with replacement we can get the same characters, that is AAA. We'll consider it for the best case. So what we will do is current right pointer, that is I, current left pointer, that is left, plus 1 minus the maximum frequency, that is the same element we are considering for, is lesser than equal to k, that is number of replacement. That way we know key it is valid, the substring is valid. So we could replace the answer with the maximum answer. So answer minus 1 minus left, that is the window size, plus 1. So after that we could simply return the maximum answer, that is the answer. So let's see if it is working fine. That is working fine. Let's check for all the cases. Yeah, so it did work fine. So the time complexity of this code will be we are iterating over the string only once, so that is n, and we are making a computation. So let's consider them O of like one time only, so O of n in total. And we are using a constant size, that is only 26 characters. So that will be also O of 1. Yeah, so that's it. Thank you.